Thank you, everyone, for joining us today. We're celebrating our 75th anniversary of the Astronomical League this year. 75 years will be done on November 15th, 2021. Um, it's been a fast 75 years. The league has grown quite a bit. We're now up to 18,000 members and over 300 clubs across the country. Over the next few weeks or so, we're going to be presenting a number of programs spotlighting different aspects of our hobby. Today, we're going to be having a program focusing on comets, comet building, what comets are, things of that nature. Our presenter today is Skip Bird. Now, I've known Skip. I first met Skip in 1998 at an outreach event celebrating Astronomy Day. And Skip has dedicated a lot of his efforts into outreach events and bringing them to people and just bringing astronomy to the public at large. He is now a member of the Westminster Astronomical Society in near Frederick, Maryland. And he, there you go in the background at Westminster
Westminster, Maryland.
Westminster. Okay, gotcha. And he's also a, let me see if I get this right. He's a NASA Heliophysics Ambassador, and he's presently the outreach director for the WAS, the Westminster Astronomical Society. And he has, he really likes outreach. He likes bringing it to the public, to the people. So we have him on today to, well, I'll let him say what he's going to talk about. Thank you, Skip, for joining us. I'll just turn things over to you.
Thank you, John, for that glowing introduction. Most of it was true. So, all right. Hi, I'm Skip Bird with the Westminster Astronomy Club. Today, we're going to be doing a program called Chicken Little Was Right. All right. The sky is falling. Okay. We're going to talk a little bit about comets. We're going to talk a little bit about meteorites. We're talking about a lot of things that fall out of the sky too, but not very much of them. Okay. So what I'm going to do is I'm going to show you how to make a comet. Now, I need your help. Even though I'm talking, this is recorded, I still need your help. Okay. All scientists are what we call observational scientists. They're always observing things. Like a chemist, he mixes two chemicals together and he gets something like this. But you know what? He mixes them together and goes, I'm thirsty. Let me run down to the deli and get something to drink. And he sitting there drinking something, he looks out and there's a big fire flash and everything like that. He goes, He walks back and wonders what happened to his building. He didn't stay there and observe. Okay. A biologist is observing. He goes and gets a big lion, he gets a lamb, puts him in the same cage. You know what? I'm kind of hungry too. He goes back to the deli, gets something to eat, comes back, and there's a really fat lamb. What happened? He wasn't observing, right? But that's all everybody does, whether they're an accountant, a nurse, a doctor, an engineer, everybody does observing. So I'm going to need your help because we're going to make a comet today. And the comet has several hundred thousands of different kinds of chemicals in it. But we're only going to use a few today. So I need your help. So what I need you to do is, if I say something wrong, like my hat is blue, not green, okay? My hat's really green, but if I say it's blue, raise your hand, say, Mr. Science Guy, that was wrong, okay? All right. Wait, it's not blue? It's not green? What color is it? Oh, it's white. Never mind. See, I was wrong. So you should be raising your hand, screaming and hollering at the screen, okay? That's okay. Now, so like I said, since I got John here today, he's going to be my audience, but he's going to help me out. All right, so there are hundreds of thousands of chemicals in a comet, but we're only going to put in 5 today. 5 chemicals, all right? Because we don't got time to put them all in there. It's just 5. Yes, I have 7 fingers up. Good job, good job. Wait, let I have 7 fingers up. 1, 2, 3, 4, 5, 6, 7. Hey, whose turn is it? Your turn? Your turn, your turn. Okay. These guys are excited, but it's not their turn. They'll come back later. All right, we're going to put in 5 chemicals. The first thing, one of the major ingredients of a comet is rock, not dirt, because dirt's got live things in it and dead things in it, but rock, okay? Now, for this example, my rock is recycled asphalt, all right? Nice and black, all right? Recycled asphalt, dirt, you can use dirt. I like the recycled asphalt. I get it where they dump after they clean the driveways with, or the parking lot. Now, one of the things I'm going to talk about when we're talking about comets is that, anybody ever seen a meteor shower? Raise your hand. All right. All those who have not seen a meteor shower, turn off the TV, put down the video game, and go outside and look up. Okay, you'll see a meteor if you stay out there long enough, an hour or two or less, you'll see a meteor. That meteor was caused by, I'm going to zoom in on this, caused by that little bitty rock. See that little bitty rock? That's actually a very big meteor. All right, that little meteor was caused by that rock. You're going to go, well, how can that little bitty rock cause that big flash of light? Well, I'm going to show you. Why don't you put your hands together like this? All right, everybody, put your hands together like this. All right, good. Now rub them slowly, faster. Now really press hard. Ow, ow. Now smell them. Ooh, smells like burnt flesh. You did. You go, Mom, Dad, guess what I learned today at Mr. Skip's class? I learned what burnt flesh smells like. Let me show you. You actually created enough friction to burn up the dead cells in your hand, and that's what you smell. And that's how that little bitty rock creates that big streak of light because of friction with the atmosphere, okay? All of our meteor showers come from comets. Technically, there's two that comes from asteroids, but they got cometary. They think they're just dead comets is all they are. But all of our meteor showers, all 42 of them a year, come from comets, okay? Now this is not a meteor. This is a meteor wrong, okay? This is actually a piece of asphalt. Looks like this is I call this the movie meteor, okay? This is an actual meteor. It's a meteorite. So you got meteor wrongs, you got meteorites, okay? I've also got one right here. I'm going to show you real quick. Right? See that one? That one looks just like a rock. And that's exactly what it looks like. This is the nickel iron one. All right. I mean, sorry, this is a Sony iron. So it's got a little bit of iron in it, but mostly it's rock. If you saw this laying on ground, you'd never know it was a meteorite. This one was found in the northern Sahara where a bunch of sand is. So when there's rocks out there, there's a good chance they're meteorites. This one, this big nickel iron one, you hear it drop. This was found in Russia. All right. So we're going to go through that. But again, meteorites, meteorons. So that's our first ingredient in a comet is rock. And that's where our meteor showers come from. Now, the second most plentiful chemical in a comet is not ammonia, so don't get excited, is methane. You know what methane is, right? Beans, the musical fruit. The more you eat, the more you make methane. All right. So I couldn't use methane at this time because methane is very explosive and it's a gas at this temperature and pressure. So if I was opening this up, my son's over there taking a picture, there'd be a spark, there'd be a flame, my hair would be on fire, and they'd never invite me back. Okay, can't do that. So I'm going down the list. Oh, look, the next most plentiful chemical after methane is hydrogen cyanide. Ooh, hydrogen cyanide. Wait. That's one of those big words. Let's break it down. Hydrogen. I know, I make that in chemistry class. You put a match to it, it blows up. Again, there goes my hair again. And by the way, see, too many explosions already, all right? So that blows up, they wouldn't invite me back. And I said, what's cyanide? Oh yeah, I saw that in a movie one time. They gave it to a guy to try and kill him. So if it blows up and it kills you, it's got to be really, 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 very, really, 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 really bad for you. Question, how many berries did I just say? Nope, not 3, not 6, 1. I said, it's really, 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 very, really, 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 really bad for you. Good job there, good job. I saw a couple of fingers up there. All right, that's the way to go. Really got bad for you, so we can't use that. So I'm going down the list. I go, oh, wait, the next most plentiful chemical in a comet is ammonia. Now, I found out something about the ammonia. The ammonia determines whether or not this blows up. Unfortunately, sometimes it does go boom. So if it starts smoking and hissing and bubbling, I'm not going to yell, run, it's going to blow up, because we'll have people trampled left and right. Somebody will get killed. If it blows up, we might lose an eye or a finger, something like that. We might just lose a finger, okay? Right? So I'm not going to yell. I'm going to go, can you hold this a second? I got to run out to the car. I'll be right back, okay? Hold this for me. I'll be right back, okay? Again, if it starts smoking and bubbling and hissing. And I figured out after a few years of doing this that it's the amount of ammonia you put in there. Now, I don't know about you guys, but has anybody touched a hot stove with their hand and burnt themselves? Yeah, I raised 3 hands because I've done that more than once, even though I knew better, okay? Well, because I know the ammonia is the part that causes it to do that, I'm very scared of putting in here. So you really only want a little capful. But that's usually if I had somebody here, I'd have them poured in because I'm that scared. But I'll try. So again, I just want a little careful. I don't want to, if I put in too much, then it's most likely going to be exploding. If I don't put in enough, I think it does then too. So hold on a second here. I got to center myself. Okay, ready? Hold on. I can get. I can do it. I can do it. All right. All right. I can do it. Here it goes. Here it goes. Here it goes. Now you don't want to put in too much. Uh-oh. 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 I think I put in too much. All right. Anybody have never smelled ammonia? Here, smell this. Woo. Ah, man, nasty stuff. Nasty stuff. So that's ammonia. That's the second most plentiful chemical in a comet. All right, let me mix that up. All right. The third most plentiful chemical in a comet is the thing called, can't read it anymore. It's called polyaromatic hydrocarbons. Polyaromatic hydrocarbons. Polyaromatic sorry. I read it runs together around the tube here. All right. Polyaromatic hydrocarbons are long chain molecules found in outer space and giant clouds. They're found in everything alive. They're found in plants, animals, viruses, bugs, aliens, people, everything. They're found in everything. They're found everywhere. And so that's hey, they're found in outer space. They're found here. That's probably where they came from. We don't know 100%, but that's what we assume is how they got here to Earth. Now, polyaromatic hydrocarbons, being long chain molecules, are very hard to get. If I go out in outer space and I gathered up enough of it to make that little bit there, this would be worth tens of millions of dollars. Okay. Now, I can't go out in outer space, so I'm going, how can I get polyaromatic hydrocarbons here on planet? I had a brain fart. No, that was the methane. Oh, I had an aneurysm. No, that was the hydrogen cyanide. Oh, I had a thought. If it's found in everything alive, it's probably found in everything. Yes, that's right. Found in everything dead. All right. Found in everything dead. So before these programs, I walk around all the corners and stuff. I look around and I go, oh, look, some bugs. And I go put those in the blender, add some water. And if I'm really lucky, really lucky, I'll find some stink bugs. Because I know they got to be full of polyaromatic hydrocarbons because they smell so bad. All right. I throw them all there. Now, the other day, I got really lucky. I found a mouse in a mousetrap. So I threw it all in the blender because I figured it's got polyaromatic hydrocarbons. Blend it all up, run it through a coffee filter, pour it all in here, and that's where I get polyaromatic hydrocarbons. Now, to do this for our comet, because our comet, what the comet is a giant dirty snowball. Most of the ones out in space are several kilometers across, but there's no size. One we can make, if it was in outer space, still be considered a comet. But the way they do that is, you all know when you're trying to make a snowball, it's got to stick together. It can't be just powder. It's got to stick together. So the polyaromatic hydrocarbons is what I use to stick together. And there's only one way to test the consistency. Now, I've got it colored blue, so it's hard to see, just because it's a real nasty looking green. Polyaromatic hydrocarbons, the only way you can test it, all right? Oh, nasty stuff. You got to make sure it's consistent enough. Whoa, almost put it in there. Can't put it in here because this is dihydrogen monoxide, very deadly. I'll come back to that one later. Let me put it over here in the water. All right. All right. There we go. The polyaromatic hydrocarbons. Now, all right, the fourth thing that's in a comet, the fourth chemical, most plentiful chemical in a comet is a rubber glove and a hammer. Wait a minute. 1, 2, 3, 4. A rubber glove and a hammer. If we ever find a rubber glove and a hammer, we're in trouble. Because that means whoever put them there, worse polluter than we are, okay? A rubber glove. Oh, I know what the rubber glove and hammer for. The rubber glove is remind me to put it on, so when I reach into my box and pull out my frozen carbon dioxide, I won't burn my hand, okay? Wait a minute. Ow. What's going on here? Why is my hand hurting? Oh, that's because I didn't put the glove on, okay? Sorry about that. All right, I'm going to put the glove on now. Why I don't put the glove on. Okay, there it goes. Now I can pick this up. There. See that low? Some people call this frozen carbon dioxide. Some other people call it dry ice. And on one of my chemistry programs, we talk about why it's considered dry ice, but it's actually frozen carbon dioxide. What you see coming off of it is water vapor. It's so cold that when I blow my breath across it, water vapor condenses, makes clouds. Okay. Now, what I was saying with this, you see this going up in the air like this, okay? All right. I do this so you can see it going up and down. Did you see it go? Where'd it go? Oops, sorry, I knocked one of my meters off. What happened to it? Oh, wait, there it is. I must have dropped it. All right, sorry about that. Okay, this is called frozen carbon dioxide. Now, at this temperature and pressure, it is frozen. Now, if you notice again, it's turning to water vapor because frozen carbon dioxide is about 108 degrees below zero. Reason I'm not holding it in my hands, my hand's 98 degrees above zero. That's roughly a 200 degrees difference. Frozen carbon dioxide touches the cells in my finger, freezes the water. What happens when you freeze water? Yes, that's right, it expands. When it expands, it causes a blister, the cells in my hand blow up, and my finger suddenly goes, ow, that hurt. Okay, so we can't do that. Now, remember that hot stove we touched earlier? Again, my finger's 98 degrees above zero. I hit that hot stove. It's probably a hot burner, probably about 300 something degrees above zero. All right, that's a 200 degree difference. Water, when it turns from water to steam, guess what? It expands. The cells in my finger rupture again, and I get another blister, and I go, ow, cold or hot, I get the same thing, and ow. All right, so we can't do that. Right? Wait, what happened? Oh, wait, I was supposed to. I knew there was a reason I had to put something in there. Now, I used to use my hat when I break this stuff up, but I found that when I put it back on, I get brain freeze. So what I'm going to do, excuse me a second, I'll reach down here. Okay. Is I'm going to reach in here and I'm going to rush it all up. Okay. Because if I do it too soon, you don't see, it doesn't get the same effect. Now I'm going to move this out of the way for a second. I'm going to beat on, instead of beating on the table, I'm going to beat on the floor. Now, ignore the man behind the curtain. Batteries are not included. No animals were hurt during the making of this presentation. They were already dead. And the views of the management in no way were reflected by the views of the scientists. Okay. Okay. All right. All right. So now I'm going to dump that all in there. Okay. Dump it all in there. Turn it inside out. Get rid of my hat. There you go. All right, all right. Now I'm going to mix it all up. I'm going to mix it all about. I'm going to put my left foot in, my right foot out, and mix it all about. Wait a minute, wait a minute. Right foot in, left foot out. That sounds like a song. What song is it? Yep, the Hokey Pokey. All right, good job, good job. But wait a minute, wait a minute. If you were observing, I did something wrong. What was it? I said I put my left foot out and my right foot in. You can't see it, but they both went out. Okay. So I did the wrong combination. So you got to be observing around here. All right. Now, I'm all done shaking it all up. I should end up with a giant dirty snowball. Now, I'm going to try and show this to you. Doesn't look like a giant dirty snowball to me. It just looks like a pile of rock and ice. So hold on a second here. Why didn't my comet work? Yeah. Yes. You? Nope, that's not it. Okay. How about you? Nope. Why didn't it work? All right. Oh, there you are. That guy got his hand right. How many ingredients did I say I was going to put in there? Right? 5. How many have I put in here? 4. Rock, ammonia, polyaromatic hydrocarbons, and frozen carbon dioxide. That's because I saved the deadliest for last. All right. And that is dihydrogen monoxide. One of the deadliest chemicals known to man. It's so destructive, it can destroy entire continents. Yeah, too much of it will kill you. I mean, in solid form, crush you like a pancake. Superheated form, it'll melt the flesh from your bones. It's amazing. Too much of it will kill you. Guess what? Too little of it will kill you too. Dihydrogen monoxide. So let's take a look at that. Dihydrogen monoxide, one of those big words again. So let's break it up. Dihydrogen. Di means two hydrogens. Monoxide. Mono means one. What has 2 hydrogens and 1 oxygen? No, that's not it. It's not the W word. That's right, H2O. Some people call it water, but it's H2O. Water's got other things in it, chlorine, fluorine, chemicals, all the other stuff in there. This is H2O, dihydrogen oxide. Like I said, again, destroys entire continents. Give it time, all right? So now what I did is I drew a line in here. You can't see it very well, but I drew a straight line in there. Okay, see that straight line? All right. So I only put in 237. Yeah, what? No, oh, maybe that explains. The line's not straight. That explains why it blows up. All right. There you go. See that? See that? Okay. All right. Somebody's putting their glasses. I want to make sure they saw it. So I'm going to put in there, make sure I put in the exact amount because we don't want to put in too much. Now, while I'm pouring this in here very carefully, I'm going to ask you, where are you guys from? Are you from Roanoke, Virginia? Uh-oh. 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 I missed the cup. Uh-oh. Uh-oh. It's starting to smoke. We should be okay. All right. So what I'm going to do now is I'm going to simulate gravity. All right. Simulate gravity. I'm going to crush it all up. All right. Now, sometimes I forget what I'm doing, and I'll be sitting here talking, going, what's going on? What's going on? All of a sudden, boom! All right. Woo! Lucky. All right. Wait. Oh, can you hear it? It's bubbling. It's hissing. It's smoking. Here, hold this. I got to run out to the car. I'll be right back. All right, bye. I got to run out to the car. All right, let me do that. All right. So I'm simulating gravity or playing the bagpipe. All right. So let's simulate gravity. Squish it in here like this. Ah. All right. Sorry, too much ammonia. All right. Woo. Woo. There you go. All right, there, finally. Okay, now, over the years, I've lost a lot of things. I've lost keys, I've lost toys, lost my first wife, that's a whole different story. I've even lost my kids, but my son just walked by, so I guess they found their way back from the Grand Canyon, all right? Next year, maybe we'll try Tahiti and see how they do, all right? I even lost my homework one time. Actually, the dog ate it. Really, truthfully, I don't have a dog. My teacher and mom figured it out, so I got in trouble for it. So don't try that excuse, kids. It doesn't work. But over the years, I've lost a lot of things. You know what I missed the most of all the things I've lost? My mind. Lucky for you, I carry a spare brain with me at all times, okay? Now, my brain has my name on it. So when we all lose our minds together, I can find my brain. It's a bird brain, all right? So that's my last name is Bird, all right? So again, we all lose our minds together. I got mine, so I carry a spare, all right? But lucky for me, all right, let me put my glove back on because this is still cold. All right. All right, lucky for me is that I have the third brain, and the third brain lives, all right? So here is a comet, all right? There, I'm going to squeeze in here a little bit closer so you can see it a little bit better. Okay. All right. Can you hear it hissing? Can you see that it's bubbling and smoking? Uh-oh. Bubbling smoke. Oh, no. It's going to explode. Here, hold on this. Now, the reason it's green, all right, the reason it's green is because in outer space, hydrogen, cyanide, and some other chemicals, they fluoresce under ultraviolet light, okay? So what I've done here is I've added a chemical to this so that it appears green in the image, all right, in the green in our view, which I put in the dihydrogen monoxide. And what that is for all you kids out there, it's really cool. This is actually just yellow highlighter. Take an old yellow highlighter, take it apart, drop the pieces in here, okay? When you do it like that, you put it in a jar, you can see the little pieces of the yellow highlighter in the bottom, okay? Turns green, blue turns blue. There's a couple of other colors that do really well. Yellow is the best because it looks green. Unfortunately, my glow in the dark here, my ultraviolet light decided at this point it's going to stop working. So I'm sorry about that, but it doesn't. So if we could turn off the lights, you see it glowing. But now this is the comet, all right? So real quick, let's run through what's in the comet so we know how to make it next time. All right, first, Chicken Little. Wait, no, he's not in the comet. First thing in the comet is rock. Good old rock, not dirt, but rock. The second thing is ammonia. See, it says ammonia. All right. Now, you notice anything unusual about that label on that bottle? Here, let me try it this way. There, now it's right side up. I was running late for a program one day. I needed some ammonia. I walk into there and there's a whole big wall of ammonia. There's all these jugs sitting on there like this. One jug has got its label upside down. I said, I got to have that for the class because you got to observe it. So somebody should have raised their hand, sir, that's upside down. All right. So ammonia. The next thing is the polyaromatic hydrocarbons. Again, polyaromatic hydrocarbons. All right. Now, the nearest thing to this on Earth is combination gasoline, oil, Coke, anything along those lines that has long chain molecules in it. Okay. The last one is the dihydrogen monoxide. Again, with yellow highlighter just for visual purposes. All right. Now I'm going to put that right there. Now, again, I told you before that we had meteorites and meteorons. So let me come around here. We'll come around to the front. So you're not going to see me very well. Hi, how you doing? Okay. So this is a meteoron. All right. This is actually a chunk of asphalt from their driveway. Sorry. Okay. This is a meteorite. This is a nickel iron meteorite. This weighs about 4 pounds. Okay. That's the magnet on there. So I can actually hold it from the magnet. All right. So that's how you can tell if they're meteorite. Not all of them, but some of them are. Okay. So there's the meteorite. Okay. Here is the other one that I showed you earlier. Looks just like a rock. All right. It's actually a meteorite too, because the magnet sticks to it. All right. Not strong enough to hold it. Not strong enough to hold it up. But almost, okay, almost. It's just a stony iron. This here is another meteorite, right? This is how a lot of them look. This is a nickel iron meteorite. This is a single piece, okay? Single piece that came in there. We could go through bladed edges and stuff like that, but we're not going to. So those were meteorites and meteorons. Okay. Now we're back to here. Now, y'all know that 65 million years ago, a large rock fell from the sky, and wiped out the dinosaurs, didn't it? Okay. That wasn't a meteorite. That was considered an asteroid. By the way, if you talk to most scientists, there's no difference between a meteoroid, which is one that rhymes with asteroid, which means it's floating in space, and an asteroid. There's some size differences, but one's a rock. One's a big one, one's a little one. It's like the difference between a boulder and a rock. There's no definite 12.5 inches. So big, large meteorite came down, plastered the Earth 65 million years ago, 10 miles across, wiped out the dinosaurs. Those of you who recently have been around know that in 2014, a rock about the size of this room blew up over Chelyabinsk, Russia. 60 miles up in the air, blew out windows, did a bunch of damage, hurt a bunch of people from the flying glass, and that was something the size of this room, okay? So big ones, little ones, the little ones. You saw the little one that came down, made it to the ground. Big ones sometimes blow up. There's a couple of pieces on that. I don't have a piece of that, but a friend does. So there's a lot of things along those lines. Do you have any questions? No? Okay, so let's review again what the 5 ingredients are. Rock, ammonia, polyaromatic hydrocarbons. Some people say polyaromatic hydrocarbons, polyaromatic hydrocarbons. Dihydrogen monoxide with a little highlighter color to give it this nice green look. Okay. Yes. Okay. It's talking to you. All right. Now, one last part of this program is if you're doing this with a bunch of young kids, I'm going to show you something here. I'm taking Dawn dish soap. I'm putting some of it in the water. All right. Just right there in the water. I'm going to stir it up. Okay. All right. And then I am going to add my dihydrogen monoxide, add a little color to it. All right. You can't see that well because it's not glowing, but I'm going to show you anyways. Okay. All right. I just stuck it in here because it makes a mess. Now I'm going to take a chunk of frozen carbon dioxide again. chunk of frozen carbon dioxide. Oh, by the way, if you're over 18, you can get this at Safeway sometime or your local frozen carbon dioxide store. But I'm going to drop it in here. Drop it in here. Okay. All right. Now notice what happens. The blob monster. All right. I can grab it. See what happens when I break it up? So again, it's just dish soap and water, so let all the kids wash their hands with it. You ever want to do a science project for your science program? You don't make the chemical one, the vinegar and baking powder. Make it with the dry ice. Color it red or yellow. I color it yellow, so if it gets on the floor, I can blame the dog. All right. But when it does this, it turns to smoke. It steams. You can throw it around. Okay. Make little smoke rings out of it. There went one right through there. Again, do all of this. This is something you can do with the kids. So it's very exciting and active. So try this at home if you're over 18. Okay? I'm just going to tilt it over here so that it stays inside the bucket. All right. So last thing, any questions? No questions? Yep. Okay. Yep. That one there. You can find recipes online if you need them. Look for them at the Westminster Astronomical Society. The Astronomical League will have this on recording, so you'll be able to get the thing there if you listen to it. There's other places to look up how to make a comet, different ones. The jokes, you're free to use at any time. I stole those from somebody else myself. So if you have no more questions, then I'm going to say goodnight and see you next time. Bye.
Well, thank you, Skip. That was very educational, enlightening, informative, and all that. That was pretty cool. So you think that especially during these times when a lot of people are staying at home, that they could get their kids together, get some of this, and try this on their own. It would work well for that. It'd be a good.
Yeah. It works really well because, especially if you have like a black light or something, because this actually shows up very well under for some reason my black light decided to die in the middle. You saw it glowing earlier. But yeah, I use black lights all the time. I used to use glow in the dark paint, but it didn't work as well.
Well, that's wonderful. That's wonderful. It'd be a good family project.
Yeah.
I think get a little boring, or the kids get out of hand. They can try something like that. I mean, everybody likes foaming water. That's pretty cool stuff.
Oh yeah. Especially if you put it in the. Let me put it in a smaller chunk over here. I can put it in this one here.
Yeah.
You know, and I can even do. I can pour the smoke without pouring the water.
Right, because the CO2 is heavier or denser than air.
Right. Yeah. I do a couple other programs, Fun with Physics, Why Newton's All Wet. Another one, how big is big, how small is small, I mean, how far is far, and how small we really are. Okay. I talk about scale models and sizes, and, here's the sun, that type of stuff. And
Yeah.
Do all those things. So we got a variety of, again, as you said, outreach. I probably do, well, on a good year, not like now, I do a good year. I do 100 programs a year myself.
Really, twice a week then?
Twice a week sometimes. Summertime is busier, like in July. I may be doing 30, 35 programs.
Mm-hmm.
I do daycares, homeschools. I do carnivals. I do our state fair, our local carnivals. I do some summer camps for, like schools and other stuff. Space science and astronomy, that type of stuff. Used to be a teacher after I met you guys.
It can be a lot of fun. I know it can be a lot. Outreach can be a lot of fun. I want to thank Skip for joining us today and showing us some of this cool stuff and what comets are made of and fun things you can do to make them. With be sure not to irritate your parents when you try this, but I think it gets the point across really well. And I appreciate him doing it to help us celebrate our 75th anniversary with the Astronomical League. There we go. Hey, there you go. Always up to something.
You've been around a little bit longer than I have.
Yeah. But I'm John Goss, former president of the Astronomical League, and I'm part of a group that's putting this together to try to get these informative talks out to everybody out there. Thank you for joining us. Any last comments, Skip?
Nope. Astronomy is looking up.
Okay. Astronomy is looking up. Thank you very much. say goodbye to everybody. Goodbye, everybody.
Bye.